All right. I think we are live here. So, welcome everybody who is here in this webinar with us. We will get going in just a moment or two as we have lots of people coming in now. Alrighty. Well, we still have a couple people trickling in, but I'll go ahead and get this going. Welcome. My name is Paul Meyer. I'm the editor of Acres USA magazine, and welcome to our webinar today with John Kempf, who, as you can see, is traveling to speak at a conference here this morning. So we are Acres USA. We are having our 50th annual EcoAg conference this December 1 through 4 in Madison, Wisconsin, and we'll throw the link for that into the chat. And John is going to be doing a couple different presentations, a one-day seminar on Monday, December 1st, the first day of the conference, and then speaking again later during the regular conference, which is Wednesday and Thursday. And he is going to be speaking this morning about, find the exact topic, how to save on inputs, maximizing nutrients in the soil. So our format here is we'll do about 25 minutes of presentation and then Q&A. If you have a Q&A, feel free to put that in there's a Q&A box down at the bottom of your screen. The chat is open as well, but either place, but we'll probably see him first if you put your questions in the Q&A block. So with that, I will let John get going here. Thanks, John.
Thank you, Paul. Welcome, everyone. You know, sometimes life puts you in unexpected places at unexpected times, and so it is for me with this webinar. We've already rescheduled it once or maybe twice, and didn't really want to reschedule it again when I had this conflict come up kind of at the last moment. So I'm reasonably confident of my connection in the part of the country that I'm in, and it'll be my first time doing a webinar while traveling, but we're going to have fun with it. Hopefully you can all hear me clearly. The topic that I wanted to speak about is one that I think even in this world of increasing input costs, input prices, farmers are becoming ever more conscientious and ever more deliberate about where can they cut costs and how can they cut fertilizer costs. But this particular piece is one that is still not fully appreciated and properly appreciated for the impact that it can have on overall farm economics and on crop performance. And that is how we can increase nutrient availability naturally in the soil over the winter months with microbial activity. This has been one of the big drivers of ROI and one of the big drivers of economic performance in our consulting work when we start working with farms. And so I wanted to walk through it and describe the mechanisms, describe the science behind it, and also try to provide some confidence and how we should be thinking about it. Because I don't know if it's necessarily true for many people who've been a part of the Acres USA audience for a while, but in these challenged economic times, many farmers who are coming into this space from a more mainstream agronomy perspective, when things become tight, the first things to get cut out are the things that are perceived as being the extras. So microbial inoculants get cut out, biostimulants get cut out, and instead we focus on just the absolute minimum basics. We put on minimal required levels of nitrogen, of fertilizers, and so forth, and we cut all the extraneous stuff out and focus on the minimum basics, and that actually ends up hurting us, not just in the long term, but even in the short term. That is not the most economical pathway to take if we're trying to reduce input costs. So in this conversation, I want to talk about if you're in a situation where reducing inputs, reducing costs is absolutely critical, what's the most economical, most effective way to do that? So as a framing for the conversation, for something you for us, one way for us to think about this, when we look at forage production, let's say hay production or alfalfa, we have this traditional expectation that our first cutting forage in the spring is going to be the heaviest tonnage. It's the heaviest yielding, produces the most biomass per acre. And that is true because it's true historically because of two factors. One is water availability. We often have abundant rainfall early in the spring, abundant moisture. And the second, which isn't fully appreciated, is that we often have this abundance of available nutrition in the spring, where we have a large amount of very bioavailable nutrients in the soil that were released from soil biology over the winter months. And this is why in some growing seasons, some parts of the country, as the growing season progresses, occasionally we are still blessed with generous rainfall. And even in those areas where we have generous rainfall, it is very seldom that the second and third or that the fifth cutting will approach equivalent yield and in overall tonnage and biomass as the first cutting will. And so it's not because of an abundance of moisture or lack thereof, but it's because of the differences in nutrient availability that occur that are different in spring versus later in summer. And so what is happening with the alfalfa, and by the way, we now have, I don't even want to assign a number, hundreds, we have many different examples and experiences to point to where we can point to farms and crops that were as high yielding in the third and fourth and fifth cutting as they were in the first and second. And that is also an expression of biology, but that degree of biological activity, again, there's moisture requirements that have to be met for that to become the case. But that degree of biological activity can take time to develop. It can take a couple of years. What I want to talk about right now in this fall to spring development can happen immediately in the first year. You can have very compromised soils with very poor biological activity, very low levels of organic matter, and you can achieve these types of nutrient releases because they're in dormant soils in the northern hemisphere. There isn't a lot of plant growth during the winter months. There's not an extraction of nutrients. That's part of what contributes to the accumulation. And the other contributing factor is that the biology never entirely shuts down in soil during the winter months, not even when the soil is completely frozen. It slows down, but it never entirely stops. So let's look at this. Can I progress here? Well, for some reason, I am stuck. All right, I'll stop sharing my screen. Oh, here we go. So we understand that we have high economics are challenged right now. And there's no point in discussing that further. What I think many of us don't appreciate is to the degree to which soil biology can release nutrients if they're given the winter season to do so. This is, over the years, we've had many people use our soil primer application or rejuvenate application in the spring instead of in the fall because perhaps their fall economics were really challenged. And that works. It's been quite effective. But the economic impact and the degree of nutrient release is not the same in the spring as when it is applied in the fall. So what happens during the winter months? We have no tillage or herbicide interference, and we have more fungal activity from crop residue breakdown and the humification process than we do when we put on these applications in the spring. And if we stimulate biology in the fall, I'm going to get into some of the mechanisms behind how this works and how to accomplish it. Let me see if we'll see if we have some results to talk about in just a little bit here, but I don't think many of us really appreciate the quantities of nutrients that can be released. If you take a corn crop residue and let's say there's 100 units of nitrogen that are contained in that corn crop. It is common without, if that corn residue isn't treated and it's just left to decompose naturally, of course, a lot of that carbon dioxide is going to volatilize into the atmosphere. It's going to be digested and move off. And the nitrogen will go with it. But that is often a process. It depends on the soil's native biology and the corn genetics that are used. But if you're using VT corn that has very hard stalks, a lot of lignin, that process can take a couple of years. With a little bit of stimulation from biology, you can have greater than 80% of the nitrogen that's in that corn residue be unreleased and available for the crop by the following spring. So all of a sudden, you've gone from soil that might have had 20 or 40 or 50 pounds of nitrogen in it to go plant into, and now you've bumped that by 80 to 100 pounds. And that's a pretty significant deal and a pretty significant win. So I already spoke a bit about the difference between spring and fall applications, but in short, when to give you kind of a macro geological perspective on the difference between fall or winter nutrient or winter biological activity and summer biological activity, I want you to think about it in terms of latitude. Think about what the soils look like and what organic matter converts to in Alberta and Saskatchewan versus in New Mexico and Arizona. The difference is that in colder weather, when you have biology working on crop residues in cold soils, all of the chemical reactions slow down and the biology slows down. And in that environment, fungal activity becomes dominant. And so because you have primarily fungal digestion in cooler soils, this leads to more humification and the conversion of the carbon that is contained in crop residues converts to stable organic matter, it converts to humus. And so you have the soils further north, or in more accurately saying in colder climates and colder environments, turn black. They get this black humus buildup much more readily than further south. If you go down to the soils in southern warmer zones, they'll tend to be more reddish soils. And even when they build up higher levels of organic matter, 3 to 4% organic matter or higher, those soils don't become black very readily. They stay, and that's because the organic matter fraction that gets built stays more of the golden amber honey color than it does the dark black. And the perhaps the purified solution version of this is thinking about the difference in humic acids versus fulvic acids. Or if you are, if you're familiar with raw materials of mined lignite, formerly called leonardite, these raw humate ores, lignite ores, the ore that comes out of black earth in Alberta is as black as midnight, blacker than midnight for that matter. And the ore that comes out of the ground further south is this golden amber honey color. And that is an expression of temperature. So the short and simple way of saying this is that your most effective conversion of crop residues into organic matter that forms stable, long-term stable carbon and that facilitates the greatest amount of nutrient release occurs during the winter, not during the summer. This is why biological activity during the winter months is so important. During the summer, you get much more rapid mineralization and bacterial release, which is what you need to provide nutrients to the growing crop at that point. But if you are only applying biological inoculants in the spring and not in the fall, then what is likely to happen over time is you can actually you grow really impressive crops, or grow really great crops, but you don't build soil in that process as easily or as rapidly. So what happens with nitrogen? There's a I'm going to keep moving along here, but the simple way to say it is that when nitrogen from organic residue gets converted in the fall, You will have the majority, because the process, the microbial breakdown process is slower, you'll have more of that nitrogen held as organic nitrogen in microbial proteins, microbial cells, and so forth. But also, what gives plants a very strong flush of energy in the spring is a touch of nitrate. The healthiest, I shouldn't say the healthiest, but yes, it's true. The crops that are at the intersection of both the healthiest and the highest yielding are getting about 20% of their total nitrogen from nitrate and the remainder from ammonium and microbial proteins. And in order for that to happen, you have to have some nitrogen metabolism happening during the winter months. We should be thinking about nitrate as more from a plant hormonal perspective than we should from a nutrition perspective, because we shouldn't be using nitrate to drive nitrogen for vegetative growth, but it does trigger a hormonal response that drives vegetation that can then be supplied with protein nitrogen. Most agricultural soils already contain adequate or abundant levels of phosphorus, particularly if there have been phosphorus applications applied historically. The total mineral analysis that we see coming back from Midwest labs and from Regen Ag labs and Ward labs and others, this is speaking very broadly categorically, but most agricultural soils have phosphorus reserves somewhere in the neighborhood of 2,000 to 9,000 pounds per acre. And it takes time for biology to extract phosphorus. And so we get the best response if we do these applications in the fall rather than in the spring. Same is true of potassium. I'm going to go into research of potassium. So here's some of the research that we've found, and this is what soil biology can develop even in the absence of significant crop residues. So 50 to 25 pounds per acre of N just through nitrogen fixation from microbial respiration. And we have one of the things that we know is that fungi is much better at solubilizing phosphorus than bacteria is. There are some phosphorus solubilizing bacteria, but they are a very distant second best to the effects of mycorrhizal fungi and various other fungi that can solubilize phosphorus during the winter months. So we've observed some very interesting effects over the years from our fall soil primer applications with Rejuvenate and with Spectrum in terms of phosphorus response and potassium response in crop absorption following spring. And a large part of this, what is needed to really establish, in order to get this system to work well, the reason we're observing these responses is because there needs to be a minimal level of microbial activity. This is something I've spoken a bit about in the podcast, had conversations with Rick Clark about it some time ago. Christine Jones has talked a lot about it. But what is needed is, in order to have this response, we need a minimum threshold of microbial diversity and microbial activity. And the reason, so this process should occur naturally, and does occur naturally, but on many soils, it's the microbial activity isn't large enough and it isn't significant enough to achieve quorum sensing. And if it doesn't achieve the quorum sensing status, then it doesn't produce enough. Actually, I could shut that off. Doesn't produce enough microbial response. So we've found very different responses from on-farm microbes and off-farm microbes. This is something I was just having a conversation this morning with a farmer who's been using compost extracts and compost tea extracts, and they have observed about 60% of the time they get significant improvements in root size and root development in the first month or two following germination on small grains and wheat and soybeans and so forth, but that hasn't translated effectively into yield differences. And this has been our observation over time as well. And the reason for this is because the compost teas and the extracts that farmers are producing are is not I'm not saying anything negative about the quality of the product that they're producing, because I think there are many that are producing very great quality product. But the the challenge they have is species, the presence of certain species to facilitate quorum sensing. Because what happens, a large percentage of the necessary fungi and bacteria to establish a quorum sensing community are only propagated in the presence of living root systems, which is not in your typical compost pile. So even vermicompost, compost tea extracts, they're very high quality products. I'm not suggesting that they're poor quality, but they don't contain some of the microbes that are important to achieve this response. So we'd had a conversation on our own webinar earlier. It's still up on YouTube if you want to go look at it, where we've been trying to develop products that are as effective as possible and as affordable as possible in producing this quorum sensing degree of microbial activity in the soil. We introduced this product this fall called Revenant Charge. And this is a synopsis of some of the research data that we pulled. We had multiple test plots scattered into very different soil types across Northeast Ohio. But every single one of the test plots had cover crops or plant residue incorporated into them. And we got Rick Haney to conduct an analysis for us and to give us the soil health scores, or to evaluate the effectiveness of the various treatments. So there would be a complete blind assessment. And his assessment was, he said, first of all, it's very difficult for any product to produce a response in this type of environment, because we had crop residue incorporation, cover crop residue incorporation, we had ideal moisture conditions and perfect temperatures. So the scoring matrix that Rick developed, 0 is the neutral point. If you're at 0, it's essentially showing that your product performed the same as the treated control. And so our evaluation, we compared Revenant Charge to soil primer, which our historical soil primer is Rejuvenate and Sea Shield and Spectrum. And this soil primer application, another conversation that occurred just recently, was with a group of farmers from Europe outside. They're like, "What are you talking about, a soil primer? This is not language that is familiar with us." And this concept of a primer is this whole piece that I've been talking about, the critical importance of essentially what we're trying to do is we're trying to elevate soil biological activity in the absence of abundant plant growth in the Northern Hemisphere. So while the plants are dormant, while there is very limited or no photosynthesis and no sugars going to the root system, how do we elevate soil biology during that time period? Because it is that time period that is your opportunity for the microbial community to kind of leapfrog ahead, to jump frog ahead, and to give you this flush of nutrients and this flush of organic matter buildup from fall to spring. So primer has for many years been one of our top products in terms of the number of acres that it got applied on, for the very simple reason that it delivered very strong results from an economic perspective. But more recently, with ingredient price inflation, the pricing of Rejuvenate and the soil primer has just continued to go up and up, to the point where it is difficult to defend the price point for broadacre crops such as wheat and small grains that have very challenged economics. And so we've been working hard to develop this replacement product that could deliver similar results as primer, but without the price tag associated with it. So I'm not going to go into detail on these, because you can see the detail on our webinar that we posted on YouTube. But the short version here, you see the 0 line. So the 0 The zero line is the, let me see if I have it correct. Zero line is the treated control. No, wait. Zero line would be the untreated control. The untreated control also performed very well in this environment because of the ideal environment that it was in. So you can see here we have 1 gallon Revenant being the blue line, then we have 2 gallons of Revenant charge being the yellow line, and our primer application. So the primer was a combination of our Rejuvenate, Sea Shield, and Spectrum. And you can see that 2 gallons of primer, we outperformed the Rejuvenate. And so this is very nice. I'm very impressed with these results because I know how difficult it is to outperform primer with the experience that we've had with it. So here we have, we again have very strong performance on this, and there's some nuance and some detail here to describe what happened with this fall off at the end. That is quite interesting in terms of nutrient release, but I went into some detail on that on the previous webinar, so I'm going to skip that so we can get into some more questions. Similarly here on field D, the short version is basically in these two fields, because of the way of historical soil management and cover crop incorporation and the dynamics that were going on here, the control performed extremely well on these dates that appeared to be off dates. But because of having compared it to the primer and knowing how the primer performs, we still have a lot of confidence in both primer and in the Revenant charge. So here's the one that really caught my attention. Nutrient value increase. Baseline is all the way down here at 0. So this combination resulted in, I think this first data point was pulled 2 weeks after the product was applied. And in 2 weeks, we had a net increase in nutrient value. This is combining all three macronutrients together, NPK together. It was an increase in nutrient value from $80 to $100 per acre. 2 weeks later, 4 weeks after the application date, it was pushing $120 to $160 per acre. And so this was all based on fertilizer pricing and trying to see, I think the pricing would have been updated in the August or September time period. So relative to where the market was in August, September, 2 months ago, we had this significant increase in nutrient availability and PK availability spring in summer. This was with a May application. And I know from experience that this response will be even bigger from from fall until spring than it will be with a spring application. And so this slide to me encapsulates the very heart of why we should, in my opinion, the greatest ROI benefits is if we're trying to minimize budget and minimize inputs, the greatest economic response and the greatest opportunity to minimize is to put on biostimulants that have this type of effect in the fall, not in the spring. And then to measure what was released in the spring, to pull soil analysis to see what is actually needed. And what I expect most people will find who use this product, unless they're on very sandy soils, is they will find that their need for fertilizer applications have dropped dramatically. Their needs for nitrogen, phosphorus, and potassium are going to be dramatically lower than they would have expected otherwise. This to me is the heart of and the promise of being able to most effectively reduce nutrients. So I think I'm going to call it a wrap at this point. Here are some of the reference and citations that we used in putting the slide deck together. You can find these in this. I will be describing this and going into even more detail on this concept and this topic. I'll be going into more detail on quorum sensing. I'll be going into more detail on summer versus winter biological digestion at Ecoag U, the first day of the Acres conference coming up. And by the way, if any of you don't subscribe to the magazine, you're really missing out. Paul is doing an outstanding job of editing the magazine. I got my most recent edition in the mail yesterday, and I'm very impressed with the quality of the content that is there. So I'm going to pause there. Thank you all. Let's see, and I welcome any questions that you might have. Happy to entertain any topics
Yep.
as
Thanks,
long as
John.
it's related to this topic.
Yeah. So we have a couple questions that have come through in the Q&A, and I'm going to ask those first. I do have a bunch of questions that people typed in beforehand when they registered for the webinar. So if we run out of these ones, we'll go to those. But so first question, this is just, I think, a clarification. Talus is asking, are primer and Revenant charge foliar applications, or do you ever apply directly to soil before winter? And, I think the answer is you apply it
They are
directly to
they are
soil.
des- yeah, they're designed for soil application. Now they get applied across the top of hay crops and pasture crops and so forth all the time. But they're designed for soil application, and there's some interesting aspects. Some of our largest responses have occurred on soils where this product was applied on the surface and it was not incorporated and it was not tilled. Um, surface Places such as an orchard ecosystem or in a no-till soil environment. So, and then there are other farmers who absolutely declare they've gotten their greatest responses when it's incorporated into the soil, either through a light tillage pass or from rainfall. So rain, applying it shortly before rain can also incorporate it. But there's no question that we have applied both soil primer historically and Revenant charge on very dry, no-tilled soils that you think, is this product actually going to do anything, or am I just wasting my money? And you come back in 6 months and you do soil analysis of treated versus untreated, and you go, wow, what just happened? So there is no question that they do work, and they're effective even in very dry conditions and only when applied to the soil surface.
Great. Another question that it is repeated in different forms a couple places, but can you elaborate on how microbes stay active in the winter months in freezing conditions, specifically bacteria?
Um, that question might be above my pay grade. I don't know exactly how they do it, but it's very clearly described in the literature that they do so.
Hmm.
Um, it's they do slow down dramatically, but it's my understanding that they don't entirely stop. And the way the question was asked, in particular reference to bacteria, one of the foundational aspects of this is understanding that bacteria and fungal populations are disproportionately affected by cold temperatures. So the fungi will um, continue to develop and to grow and to metabolize at a proportionately higher metabolic rate than bacteria.
Good. That's helpful. How late can biostimulants be applied in the fall to maximize the return in the spring? So obviously very dependent on where you are, but
Yeah, um, I would say the biggest factors. I don't know, Paul. I don't have a good question for that or a good answer for that. We've had people apply this product in Montana and the Dakotas and in Canada on frozen soil in the fall. Like it's frozen up. It's beginning to mid-December and it's been applied. And there are distinct measurable differences and observable differences the following spring in treated versus untreated areas. So I'm sure there is a point that is too late from a practical implementation, practical application perspective. Um, we haven't done enough research to evaluate timing. Is there significant differences in timing between a November application and an October application and a December application? So I don't have a good perspective on that. Um, what I the only perspective that I do have is that I'm thinking of this one Montana operation that there were applications that were made in late November and they didn't get it all applied. They finished up the following spring and I want to say late February, early March time period. And there were observable differences where the November application outperformed the spring application, even though it was applied very early.
great. Um, Nick is asking, in a northern climate, zone 5A, assuming biology is applied in the fall, would late winter and early spring mineral applications work well together to maximize efficiency? This is for organic vegetable production.
Yeah. Yeah. So if we have compost is kind of its own ball of wax here, but let's say that we have soils and we're growing crops that require the addition of additional phosphorus or additional potassium. If we're putting on, from an organic perspective, if we're constrained to using rock phosphate, putting on rock phosphate in the fall with this type of application is going to lead to a much greater phosphorus availability response the following year than putting it on in the spring. Absolutely.
Good. There's a number of questions that touch on the topic of measuring soil biology so that you know what you have and therefore what you can input, what you can stop paying for inputs for, etc. Do you want to take a general stab at that?
Well, the first foundational premise is in order for us to be able to manage this well, we first have to be able to measure it, and which is part of what the question is referring to. Um, I'm not. We've looked at a lot of PLFA analysis. We've looked at different microbial analysis with I'm forgetting the microbiometer and various tools, biome makers analysis. And I think all of those provide us with some interesting insights, but I've not figured out how to make management decisions from that data, from the data that is revealed there. What do we add? What do we take away? Or not in a significantly worthwhile way. So this is one of the reasons why we've made investments in the microbiome DNA sequencing lab, which, given everything that has gone on for us as a company the last year, we had hoped to launch it this spring, and that ended up being delayed. But that is progressing, continuing to move forward. Hopefully, we'll have DNA sequencing commercially available in another 3 to 4 months from now. That will be very affordably priced and readily available. And then at that point, hopefully, we'll have more data that we'll be able to make good management decisions from. And I think, I don't know, as time goes on, I'm well, I suppose there are lots of hypotheses that are about to be proven or disproven once we actually have data. That's what happened with SAP analysis, is all of a sudden our understanding of nutrient interactions in plants took a great big leap ahead. And I expect the same to happen with once we're able to measure soil biology. But I'm persuaded that um, we're perhaps paying too much attention to individual species and not enough attention to broader categories. But that's my hypothesis at this point. We'll have to dig into that once we have better data.
Good. Yep. I will answer this question real quick. Someone just asking if we can send your reference list out to the audience. And yes, we will send John's slides and a link to this presentation all out to everyone who is registered. So no worries about that. And Carrie is asking, we live in Alaska where the soil stays colder than most other places. Can we struggle? And we struggle with slow breakdown of residue. Any recommendations for helping encourage mineralization earlier in the summer in these cooler soil conditions?
So your environment would be an appropriate environment for a spring application. It could be either or. It could be both a fall and a spring application, or just focus on a spring application, because a spring application of a biostimulant like the primer or like Revenant charge is going to lead to very rapid mineralization.
And then we'll ask the opposite question. Patrick Van Haren is asking, the majority of listeners are in the northern growing zones, but in zones like 8A, do fungi respond in the same way during the summer dormant months?
Do fungi respond in the same way in the summer dormant months? Um, that question could be interpreted in different ways, but the short answer is that Revenant charge or the soil primer application will both they increase they're non-targeted, they're non-selective. They elevate the entire microbial community altogether. And then it is in the with the fall application, it is the winter and the temperature conditions that favor the development of fungal populations versus bacterial populations. So in a warmer environment, the same would be true during the winter, but the opposite would be true during the summer. So if you put on a spring application in warm weather conditions, the same application that will stimulate fungal dominance in the winter will stimulate bacterial dominance in the summer, just because it's an overall general biostimulant.
Good. Here's a question from Ian Gold, who, yeah, we know from the
Ian?
UK. Yeah. Should we be growing a fast-growing multi-species crop in our compost pile before making a compost extract to add these missing elements associated with living roots?
It's certainly worthwhile, and you should also consider the particular types of species, and you should consider inoculating those as well. So the short answer is yes, that is something very worthwhile considering.
Good. And then another compost-related question, Joseph Winter is asking is,
Mile
um,
for 110 towards St. Mary's.
go to St. Mary's. Is it, he says, is it increasingly accepted that the success of compost tea and extract applications as biostimulants is rooted in their capacity to deliver a reliable suite of signaling molecules and microbial metabolites, that those are the real active ingredients rather than a direct transfer of viable microbiota alone?
That is a large part of it, and there's increasing recognition that I don't know, Paul. I'm of two minds on this one because the signaling mechanisms and the signaling molecules are extremely important. And also, there are species and groups of species that are very impactful, and they do succeed in establishing a viable population. And this is a point that I just fundamentally disagree on. There is this discussion that, well, when we're adding compost tea or we're adding a microbial inoculant, we're adding these comparatively tiny quantities of microbes to soil that is filled with billions of times more than we're adding. How could we possibly expect them to build and establish a viable population? And the problem I have with that argument, and again, we're short on data, and microbiome DNA analysis, I think, will answer all these questions for us. But we've been doing exactly that for 60 years with azotobacter, or excuse me, with azospirillum, with nitrogen fixation organisms for legumes. We've been adding a single microbe inoculant at grams per acre rates, and we expect to see successful establishment of that community. We expect to see legume nodulation. And so the hypothesis that that cannot work or doesn't work just because of mathematical numbers alone, I don't think holds true. I think there is an element of need to be in proxy to need to be supported or recruited by that plant. So there are other elements in play, but I'm of the persuasion it's absolutely possible to introduce new species to a soil environment that haven't been present previously, and to have that have very beneficial aspects, even when you're applying it in grams per acre application rates.
Good. Here's a question. Will this product be required every year? Will there be a point at which the crutch can be dropped?
You should achieve a state of soil health where this product is no longer necessary, or any other product is no longer necessary. And that depends on crop rotation. It depends on your overall soil management practices, how that soil is being physically abused or not abused with traffic and tillage and cow hoof action, and the list kind of goes on and on. But you know, one of the most exciting, I've been able to work on many exciting projects, but it's pretty rewarding to have alfalfa fields that are producing the same yields in the last cuttings of the year as they are at the beginning. And because alfalfa fields historically are extremely compacted, they're compacted and compactable, not just because of the traffic that they get from harvest, but also because alfalfa fields generally are known for depleting carbon because they're a legume. They supply lots of nitrogen to the soil. They produce a narrow nitrogen to carbon ratio, and they do deplete the soil of carbon, and the soil loses its structure and it becomes very compactable. But when you get biological activity to a point where you have this release of nutrients all season long, that is associated with good humification and fungal decomposition. That means you also have proper cycling of carbon. And it's entirely possible to have the yields at the end of the year be the same as the yields at the beginning, have similar nutrient value, and to not lose soil structure because we have good carbon cycling. And that's a lot of fun.
Another question on a specific context for this: coastal Northern California, 1 or 2 ground freezes per winter. How would you apply this?
I wonder if my friends from Crescent City are here on the call.
James Bledsoe, I'm not
Yeah.
sure.
So the optimal is soil application when soil temperatures are cold rather than warm. Now, if you're or cooler, if you're coastal California, depending on how close to the coast you are, you'll have relatively cool temperatures for much of the growing season. But you still have seasons. You still have summer, winter, and of course, generally, I think your winter is you have a lot of rainfall, and in those environments, I would still prefer a fall application to a spring application because I want abundant nutrients available for high quality forages and high quality growth the following spring.
Right. Here's a pretty in-depth question. Stephen Fabian is asking, what's your opinion on the role of soil microbes contributing to either plant particulate organic matter or mineral associated organic matter beyond the breakdown of plant residues, but rather microbial contribution themselves?
Um, Mr. Fabian, I know you. I'd like to shake my finger at you here. The best, well, there's some of the I'm blanking out. The tri-societies have there's a book that was published now close to 20 years ago that is titled something to the effect of soil minerals, microbes, and organic matter, something to that effect. And there are some pretty fascinating, some quite fascinating research that is reported there. And the short version, if I'm understanding your question correctly, is that what really we've identified these different molecules that are very important, such as glomalin, for example, glomalin coming from mycorrhizal fungi. And I think the proper way for us to think about it is that almost all microbes, we've identified glomalin as one, and I expect that we will identify the contributions of specific compounds from all types of different soil microbes to be essential for forming this mineral associated organic matter. So there are the lipid components, the phospholipid components coming from bacteria. There's a lot of different pieces that are contributing to it, and that's I don't have a specific detailed scientific chemistry answer for you right now, but just very broadly, contributions of biology are fundamental to building mineral associated organic matter.
Stephen has another question. You're going to shake your finger at him again. He says, what's your opinion on applying small amounts of nitrogen in the fall, which I've heard you say many times is like the stupidest thing farmers can do. But at the same time, applying small amounts of nitrogen in the fall at the same time as the microbial inoculum and biostimulants to help expedite the conversion of broad C to N plant products into microbial biomass, which is more
Yeah,
narrow in C to N.
yeah. It depends a bit on the soil context, but it depends on how you define a small amount. But my commentary, my historical commentary on fall applications of nitrogen being a very dumb idea are not relative to small amounts, Paul. They're relative to large amounts where people are putting on large amounts of nitrogen into the soil and so forth. Um, so we know that there is this stoichiometry, this chemistry balance that needs to happen for optimal to form optimal levels of mineral associated organic matter. There is this optimal balance of carbon to nitrogen to phosphorus and sulfur. And it's very common for us to have conversations about carbon to nitrogen ratios or nitrogen to sulfur ratios, but we often don't look at that combination, the full spectrum, the full combination. So if we want to take this stoichiometry approach to balancing calcium, phosphorus, carbon, my goodness, to balancing carbon, phosphorus, nitrogen, and sulfur levels, to do that accurately, to do that well, we also have to take into consideration what the soil is capable of delivering. Because during the winter months, the fungal population is particularly good at accessing those other elements, N, P, and S, if they are present in the soil profile. So I wouldn't be immediately dismissive of the idea of a fall nitrogen application, but what I would suggest is what is probably going to happen, you'll have a narrower carbon to nitrogen ratio. You will stimulate bacterial populations more relative to fungal populations. And that could conceivably lead to more mineralization and more nutrient loss in the fall and over the winter months compared to the spring. What I will say is this. We don't yet have the depth of experience with Revenant charge, although I have every expectation of having similar results. But with the soil primer application, you do not need to add nitrogen to get residue to disappear by spring. You can have a 300 bushel per acre corn crop, a very, very heavy corn residue, and put on an application of primer in the fall, and that residue is 90% gone by spring. So if the idea of adding nitrogen is just to get more rapid residue decomposition, it's not necessary with a good biostimulant.
And small means, I mean, no, you can't define it exactly. You're muted now.
More than 3 to 5 pounds per acre of nitrogen is going to be necessary. Anything more than that, at some point, you're going to start having a detrimental effect by putting it into the same tank with the biostimulant.
Good. Okay, Hania is asking, do you think that today's, actually, that wasn't the one. Here we go. If adding new microbes via an inoculant to an environment that previously didn't have those microbes, are you worried about the potential for them to become invasive?
No.
Yep.
There's a fascinating paper published. There's a fascinating paper that was published Nature a year or so ago. I wish I could shut this thing off. Where they looked at the microbial community of the entire globe, and they looked at microbes carried in the jet stream and wind currents. And they described in essence that there are seven microbiome environments that encircle the entire globe, and that the uniformity of the microbial population between continents was much greater than the variation between them. So this whole idea of invasiveness and of us being separated from continent to continent or from one region to another is proving to be largely a fallacy.
Good. And speaking of continents, it's nice that we get folks tuning in from all different places in the world, and maybe we'll just end on these two different questions, not exactly on this topic of fall soil primer applications, but uh, Krishnendu from India is saying that they work with 1 million small organic farmers in India and Africa. They're doing things like composting, vermicompost, liquid manure, teas, and just wants your expertise, your thoughts on biochar, how that might help. The very, very basic, broad question, but
I'm not enthusiastic about biochar. Um, for the very simple reason their char is of wildly varying qualities. And um, I've not observed char to reliably or even hardly at all produce a crop response or to produce a positive, significantly positive soil response. You want to avoid char that has an alkaline pH above pH 9. Then at that point, it becomes closer to ash than it is to char, and you reduce your negative, your potential positive effects. Olivier Houssan and his colleagues have reported some very positive responses from char that was treated with iron sulfate prior to charring so that they would produce a paramagnetic char. I think that's something that more people need to take a look at. Um, the the thing that is commonly described as it could be a possible agronomic benefit from char is when you're charging it with a microbial inoculant as an effective delivery mechanism for microbial inoculants. And claiming that there is better establishment with that approach. I've not seen any data around that. That could conceivably be true. So it could be useful, could possibly be useful as a more successful establishment carrier material for microbial inoculants. But in terms of biochar itself, or even biochar with most of the compost teas that I've observed, I'm hesitant. I don't want to be just the bearer of bad news consistently, but I've seen hundreds of biochar trials at this point, and not a single one that I've been particularly enthusiastic about the results.
Yeah. No, that's so good. You gotta call it like you see it. And then last question, working with some folks in Bangladesh, the history of the soil they're working with was rice on rice for decades, high use of tillage, urea, insecticides, fungicides. And this person is just asking about like for planting vegetables in those types of soils, what are the very basics, the first things you do for really poor soils?
Well, you need to figure out what has made them very poor soils. Do you have any arsenic accumulation from them being saturated for extended periods of time? Do you have very acidic pHs? Are they highly reduced? So those are some of those foundational biophysical characteristics I would look at if they've been saturated for extended periods for weed control. Then we probably need to look at adjusting the redox to make them slightly more oxidized. That can be accomplished with a small limestone application. You can do the same thing with, and that can also adjust the pH if necessary. But soils that are saturated for extended periods, in addition to having nutrients leached out of them, are also, they can easily become, their microbial population shifts. So it's very worthwhile to grow a cover crop. I would particularly recommend, there are a couple of cover crops seeds that are very effective vectors of a microbiome to help recover that situation. Oats and buckwheat are high on the list, and also chickpeas are one that I would recommend because of the specific microbes that they contain. And then beyond that, just a diversity, but address some of those foundational soil biophysical characteristics, and then establish a cover crop. Even if you don't even have to grow the cover crop very large to grow lots of biomass. If you grow it to 6 to 8 inches tall, and I'm thinking of these species as vectors of microbes to reestablish a different microbial community, and then go into vegetables, I think you'll have a much greater likelihood of success.
Great. All right. Well, thank you so much, John. I know you're getting close to your destination there. Um, for everyone, we are going to be emailing out this presentation. It'll be up on YouTube pretty shortly, and then we'll email out John's slides as well. And then conference.acresusa.com is the website for our 50th annual EcoAg conference in Madison, Wisconsin, 1 through 4 December, and John will be speaking there several times. And you can come. The best thing I think about conferences these days is you can hear all these presentations and webinars and YouTube and etc., but get to come and actually meet people and ask your specific questions and get that face-to-face interaction that's really vital. So,
Yeah, thank you, Paul. I'm planning to be there for the duration of the event from the beginning to the end. I'll be bringing my family. Would love to see all of you and chat with you there. And do subscribe to the Acres magazine. I hope you come to the conference. And for some of these products that I've been talking about, check out our website at advancingecoag.com. You can find some of these products there as well and get some more information on some of the trials we've been conducting.
yes, excellent. Thank you. All right. Thank you, everybody. Have a great day.
Thank you all.